I'm going to talk a little bit about an application of torque in everyday life, or in this case, what would be at work for me. And where I used to work at, we would have very large bolts on very large equipment, and we would use an impact gun. Here's mine, my Ingersoll Rand. And we would use those to put bolts in, take bolts out. Sometimes the bolts would be stuck really hard, and so we would have to use a very large wrench, such as this, which, yeah, or with a cheater pipe. And I didn't actually measure that wrench, but for the calculations I'm going to just call it 1.5 feet. And sometimes we would have to use about a 10-foot long cheater pipe to break these bolts loose. So I wanted to kind of compare that to the torque ratings for the gun. I looked up torque ratings for this impact gun, and it said delivers 1,350 foot-pounds of nut-busting torque, 930 foot-pounds of max reverse torque, and 900 foot-pounds of forward torque. I'm not exactly sure about their labels, but I think that the 1,300 foot-pounds of nut-busting torque sounds to me like the torque that would be used for breaking a bolt loose. So that's what I'm going to consider. So just how does that compare to the torque that I'd be getting from my cheater pipe? So we have torque equals force times the moment arm. And if we draw our little, little nut. And here's the length of the wrench, which that is the moment arm. And this is our force. So for the beginning, let's just say that we had our wrench on there horizontally, so that our force, for the force I'm just using my weight. Maybe it would be a little more because maybe I could pull a little harder than just my weight, but I just used my weight for simplicity. So we have, if we just calculate one of these here, we have torque equals force times the moment arm, which equals, and I converted my weight, I'm approximately 72.6 kilograms times G, and then the length, 1.5 feet, is about 0.457 meters. That would be just my wrench without my cheater bar. And this is going to give me about 325 Newton meters. And the rating that we're going with, 1350 foot-pounds, is about 1830 Newton meters. So with just the regular wrench, I'm pretty far off. I don't have time to do all the other calculations, but let's say if I had a 10-foot cheater pipe, then I would be getting 2,170 Newton meters, which is more than my 1830. Now if I had my cheater pipe at an angle, which is much more likely, or my wrench at an angle, I'm not going to redraw the whole wrench because I'm almost out of time. In this case, there's the moment arm, there's theta, this is my force. Still using gravity, we get torque equals force times the moment arm, which equals m times g times L, which this is L, times sine of theta. And if you plug all that in, you get 1530 Newton meters, which is slightly less than the torque of the gun. I think it might actually end up being comparable in reality, because the gun that goes through a lot of abuse and damage probably won't get the actual max torque rating that's listed from the company, and I could probably get a little more force than just my actual weight, maybe by grabbing something and pulling, or some friction from my feet against the ground that could help give a little bit of force. But yeah.